Hi everyone. In today's video, we're going to make a snake game, and it's going to look like this. In today's video, I'm going to walk you through the code that'll generate that game, and I'll also include the source code in the description below. Without further ado, let's pull up IntelliJ and get into it. Now, one thing to note quick is I'm using JDK 21. You don't need to use 21 specifically, but you'll want to use a newer JDK because some of the things that we're going to add within this code are using some of the newer features in the JDK that something like JDK 8 doesn't have. So make sure the JDK you're using is at least somewhat recent. So to kick things off, first thing we're going to do is we're going to make a JFrame equals new JFrame. And then here's where we add the title of our window. So we're going to call our window snake game. We're not going to modify this, so I'll go ahead and mark it final. And now we want to give this frame a certain size. So we'll do frame.setSize. And we can give it either a dimension or we can give it a width and a height. I'm going to go ahead and give it width and height. And for width, we're going to make it 800 pixels. And for height, we're going to make it 600. Let's go ahead and pull those out into private static final fields. Width of 800. And then we'll have a height of 600. And then we'll pass those into the set size method there. And now the next few things are kind of some boilerplate things that you typically add on a JFrame. So you want to indicate where it pops up. So if you do frame.set location relative to null, that will pop up the window in the center of the main screen. And then if we want to do frame.set default close operation, we'll mark that as jframe.exit on close. And we'll make our frame not resizable. So we'll say resizable is false. And then we want to make our frame visible. All right, so if we run this code, we get a window pop up. This is our JFrame with the title that we expect, but there's nothing in here. So now we need to actually add the game within here, and we'll do that via what's called a JPanel. So if I close that out, now we need to make our actual snake game class. So let's make our new snake game class here. Right click, new Java class. We're going to call it snake game. And this is going to have to extend JPanel. And what we're going to do here is we're going to say snake game equals new snake game. And we want to do frame.add game. Now the other thing we got to do is we want to make sure that we pack our panels into our frame. So how we do that is we do frame.pack. All right, so now we've got some of the main code in order to make our frame, and then we're putting a panel within our frame. So now I want to make sure that I've got the right dimensions on my game within the panel. So to do that, I'm going to pass in the width and height in here. Now let's see if the IDE can help us out a little bit. Thank you, IntelliJ. So we'll mark these as final variables, and then we're going to have some private data members. And then we'll set the values here. And one thing I did forget to do is call the super constructor because we are inheriting from JPanel here. And what I want to do is I want to make the preferred size, so the set preferred size method. This takes a dimension object. I'm going to go ahead and pass in width and height. And I prefer black for the game rather than white. So I'm going to set the background to color.black. All right, now if we switch back to our main class and we click on this green triangle and we want to run main. And now we have the window as the JFrame and the JPanel is packed into the window and it has a black background. Great. So the next thing we want to do is we want to trace out a string on here which tells the user what to do to initiate the game. So the first thing I'm going to do that is I'm going to create a new method called startGame. We'll go ahead and have it return void And then our main class is going to call start game. Now within our start game method, the first thing we need to do is we need to get access to the JComponent's graphics object. So to do that, we're going to call the repaint method, which what that's going to do is that's going to call into the Java Swing API, which Java Swing is what we're using. You'll notice that when we started having some imports here, we're using Java AWT and Java Swing. One quick note on Swing and AWT, the Abstract Window Toolkit. These are technologies that have been around for a long time. They can work and you can use them to build some applications, but if you want to build something that has real substance to it, you're going to want to use a more intense library, or you're going to want to spend more time getting your front-end UI code really good. I'm just using these here because they're good for rapid prototyping of interfaces, and they're already built into the Java development kit. Okay, so that note aside, the repaint method here, what that's going to do is that's going to call paint component on the JPanel. So if I type paint component, what this will do is it will override the implementation from JComponent, which JPanel comes from. And now we have this graphics object. So I'm going to go ahead and rename this to something that is a little more intuitive than just G. A lot of people just call it graphics G, but I like to make my variable names a little more intuitive. So now that we have paint component here, now we can add different things on the screen. For instance, since we have a dark screen, I'm going to go ahead and draw this in white. So set color, color.white. And now what I'll show is that I could do graphics.drawString. And then now we need to specify where on the JPanel the message is going to go. So if I do it at 0, 0, for example, and I run this code, we can see that there is a little inkling of the message right here. And that's because 0, 0 is going to be right up here in the top left corner. But the problem is if we start right in the middle of the screen and then we start printing a message, then that fills the message over here. Let me go ahead and demonstrate that as well. All right, so we can see here that when we print a longer string, we do start right in the middle of the screen, but then it starts going off to the right here. And that's because the 400, 300, the mid coordinates here, that's where we start printing the message. So if you really want to center something, you've got to kind of do some math to figure out how big the message is, and then you have to move the position according to that. So one way to fix that is you can use what's called a text layout, and then you can calculate the size of your text and then center it accordingly. What I'm also going to show is that if you want to draw a multi-line string, meaning that you've got multiple lines of text, there isn't an easy way to do that either. So what I'm going to do is I'm going to write a little bit of code that centers the text on the screen. And then it's going to start kind of 2/3 of the way at the top of the screen, and then it's going to keep adding text after that. All right, this is a good little bit of code. Let's go ahead and walk through this a little bit. So we talked about how we're setting the color to white. Now we want to have a certain font size because the message that we were originally printing was kind of small. So I'm going to go ahead and give it a font size of 30. The F here just indicates that it's a float. To set the font is a little weird. You basically have to get the current font and then derive a new font from the current one, and then that's the one that you want to set the new font to, if that makes sense. Whoops, I got a typo here. All right, that's better. So graphics 2D is just a two-dimensional version of the graphics object. So graphics 2D is just a subclass of the graphics class, where the graphics class is an abstract class that then graphics 2D is one of the inheritors. And currently we know that we have 2D graphics because we're making a 2D JPanel. And what we do here is the font render or context is going to get used in our text layout. But before I get to that, we have a sample message here that has this line break. We're splitting on the line breaks, and then for each line in here, Basically, we're making that text layout we were talking about where that gives us the size of the text. We're figuring out how big it is, and then we do some calculations on the width in order to center it. And then the height really is just the height of however large your font is relative to your starting point. So this is some good code to reference as far as if you're trying to center your text and you want to do multi-line strings that you draw within your JPanel. And here's an example on how that renders. So what we want to do is we want to tell the user to play the game, they have to hit the space bar. So to do that, we're going to go ahead and update our message. And then we need to implement what's called a key adapter in order to detect when the user selects certain keys so that we can know when the space bar is hit. So let's start with updating this to something like press space bar, begin game. And now we can use JPanel's add key listener in order to listen for keystrokes. So let's do that here in the start game method before we call repaint. So we can use JPanel's add key listener. So this key listener is interfaced with 3 methods. It's got key typed, key press, key release. So when we're playing the game, we want to have the game start not when the user releases the spacebar or when they type, which means that they press and release it. It's when they press it. So I don't want to have to implement methods for when a key is released or when it's typed. I only want to implement a method for when it's pressed. One of the ways that you can tailor the implementation a little bit is you can use a key adapter. You'll notice here that it has implementations of all 3 of the key interface methods, but all of these are empty implementations for a key adapter. So really, we only need to override the ones that we care about. So I want to override key pressed. So the key event class has a set of fields which indicate the type of key press event that happened. So VK space refers to the space bar. So what I want to do here is if e.getKeyCode equals space, let's go ahead and just print out a message. Space was pressed. Okay, let's go ahead and make sure that this works. And interestingly, I'm hitting the space key and I'm not getting anything printing out over here. And the reason for that is because you have to request focus, and you need to make sure that the component within your window can get focuses so that when the operating system, aka in my case Windows, delivers a keystroke, it notifies the application and then I can then process the event. So let's add some code where we request focus within our window. Okay, so these 3 methods say first, can we even focus on the window? Second, do we want a traversal key such as tab to be able to traverse different parts of the window? In this case, let's say no, we're just going to have focus on the window or we won't. And then we're requesting that we get focus right now. We can see that when I press spacebar, I am getting different things on standard out over here. So sweet, now I can get key events, and if I press other keys, I'm not getting a hit, versus if I press spacebar, I am. Cool. So this is working as intended. So once the user hits the spacebar, we're going to transition to the actual game. And this is where the code's going to get kind of interesting. So what we're going to have to do is we're going to have to repaint the layout after the game is considered started. The way in which I'm going to implement it here, there are multiple ways to do it. The way that I'm going to choose to do it is I'm going to set up a timer, which is essentially every so often the application is going to check on the status of the game and see what state it should be in. And then if it transitions states, then it will paint differently. So this repaint is going to happen quite often, and it's going to check on the health of the application quite often. So to do that, we're going to use the timer class. And instead of calling repaint here, we're going to do it within our timer action. So I'm going to say new timer. And the timer takes 2 parameters. The first parameter is the amount of delay between each firing of the event. So in this case, I'm going to call it our quote unquote frame rate, which is milliseconds. And I'm going to say that that is going to be a second divided by frame rate. And then let's go ahead and make our frame rate 20. So we'll say private static final int frame rate equals 20. So 20 frames per second, that is every 50 milliseconds. We are going to be having this timer execute another iteration within our game loop. And now we need to specify the method or the class that's going to receive the timer event when it's ready. And we're going to receive it. But if you look at the error here, the IDE is saying that the timer takes an action listener, which our current class is not an action listener yet. But we can change that. We can only extend one class, but we can implement as many interfaces as we want. So let's implement the action listener interface. And IntelliJ, help me out here. Make some method stubs, please. I want to implement action performed. All right, and then this is going to be our action event. And then now, instead of calling repaint up here, we're going to call repaint in our action event. All right. And then the other thing we want to do is we actually want to start our timer. So now what we're doing is we're going to call repaint about every 50 milliseconds. And I'm going to talk about threads here for just a second. So timer and swing in general, you have to be careful when you have different threads interacting with your GUI components. In this case, the timer class, each time that it fires off an event, it's all doing the event handling in the same thread, the event handler thread. So you need to be careful that whatever you are doing on this thread is not super heavy, otherwise your application will lag too much. But on the bright side, you don't need to worry about as many concurrency issues. So now that I've got a timer and I've got action performed, which is going to call the repaint method, I need to be able to know whether my game is started or not. So I need a variable to indicate that. So let's go ahead and make a private Boolean called game started. It'll start out as false. And what'll happen is if we get the space pressed here, then game started is going to go to true. And then likewise, when we're calling paint component here, we only want to do this if game started is not true. All right, so now we are only drawing our text when game started isn't true. Let's go ahead and run the code now and see what it's doing. All right, so our window comes up and we press the space bar and now our text disappears. Sweet. So now this is the part where we're going to actually make our snake, and our snake's going to eat our food. So the first thing we want to do is when we start our game, we want to reset all the data. And this reset game data method, we'll go ahead and we'll make this one private. It'll return void. And what our snake is going to be is it's essentially going to be a list of boxes. And the boxes are going to grow over time. So let's start by making our snake. And in this case, we're going to initialize it at the start right here. We want a java.util list. We're going to have to figure out what we're going to make the generic list of. And then that's going to be a new array list. And the problem is here we are using raw types, and that is not safe. So now we need to define what our snake is going to be made of. So I think that the snake and the food, we're going to have those look like either rectangles or squares. So now we need to indicate what the rectangle or square, how it's represented. It needs an X and a Y coordinate, and then it needs dimensions. Each square needs an X and Y coordinate of where we start drawing with the graphics, and then we need to know what the length of the sides are. So to do that, what I'm going to do is I'm just going to make a record called game point. I'm going to go ahead and have it way here at the bottom. And then for now, it's just going to have X and Y coordinates. So this game point is only going to have the starting point of where each of these squares within our snake are going to be drawn. So now we want a list. All right, that looks better. And to start, when we reset our game data, we want to make sure that our snake has no entries, and then the head is going to be a new game point that's going to be in the middle of the screen, which in this case, I'm just going to go ahead and say width over 2 and height over 2. That's not technically exactly the middle, but it's close enough because the amount of pixels we're talking about here is not very big for the actual snake compared to a long message that a user is going to pay more attention with. Speaking of size of the snake's head, let's think about how big we want that to be. So if a frame is every 50 milliseconds and we're going to advance 1 square's length worth each frame, how long do we want a user to be able to react? So let's say that you've got 1 second between the middle of the screen and the end of the screen. That would mean that you have 20 frames to do half of the width, which means that the total width is going to be 40 frames. So that would mean that the length of the square is going to be the width over 40. So let's go ahead and have another variable called our cell size. And then the cell size is going to be our width over our frame rate times 2. Basically, we're giving users 2 seconds if the snake goes all the way from one end of the width to the other, or about a second to react for the initial case. So now that we've determined how big our snake head is, let's go ahead and draw it. So reset game data is going to get called before we have set off our timer. And now let's say that the game is started. So now we're hitting this else case. Let's go ahead and do graphics.setColor. Let's make our snake green. And now what we want to do is we want to say for each point in our snake, we want to do graphics.fillRectangle, point.x, point.y, and then now here we indicate the length of the square, in this case, that we are going to paint. So that would be cell size and cell size. So basically, as our snake grows, each time that we are entering in our game loop, we're going to redraw our snake each time. And it's going to be a set of consecutive squares depending on where our snake is on the board. Let's go ahead and run this code and see what it looks like. All right, now we've got our window. We hit the space key. Now we're getting somewhere. We've got a green dot in the middle of the window, and this is our snake head. So now what we need to do is we need to get our snake to move. So each frame, the snake is going to move in a direction. Let's go ahead and by default have the snake move to the right. I'll zoom out on this code a little bit here since we're writing a good bit of it at this point. What we want to do now is we want each frame for the snake to move. So we talked about how we have this timer here, and the timer is going to call action performed each frame. So before we repaint the current frame, let's go ahead and figure out where the snake should move first. So we'll have this move method, and we'll say private void move. And what we want to do is we want to take the current position of the head of the snake. So that'll be the current snake's head is going to equal snake dot get first. I'm going to create a new head, which is going to be the current head's x coordinate and the current head's y coordinate. But if I do that, it is literally just a copy of the current head. So now I want to add on cell size here. So now this is going to have the new head basically follow the x-axis for the size of our cells here. And now I can do snake.add first, new head. This isn't what we want long term, but I'm going to go ahead and run the code just to show you guys what it's going to do here. As we can see, when we press the spacebar, immediately we create a line like this. So this isn't what we want. Basically, whenever the head moves, we need to make sure that we remove any previous entries unless the snake is actually growing, which we'll get to later when the snake is eating food. And that's not what we want to do for a few reasons. The first one is we want to remove anything that was there previously because we aren't necessarily adding on length to our snake unless it's eating food, which it's not yet. And the other thing is we currently have a bug in our code. The move here should only be happening once we know that our game is started. So I can say if game started, then I want to move. But I do want to repaint every single time. So now that I am going to only start this once the game is started and I'm going to remove the last element, let's rerun the code and see if that does what we want. So we hit space. And lo and behold, our snake is moving, but where did it go? It didn't stop. The snake should be stopping once it collides with the wall. So let's say that we hit the wall. We'd want to have slightly different behavior here. So if check collision, which we're going to write that method here in a moment. If we do have a collision, then we want to remove the new head that we just created. So we want to do remove first. Otherwise, if we don't have a collision, then we still want to remove last. So now let's implement this check collision method. It'll return a Boolean. And then basically what we need to do is we need to check to see if the head of our snake is outside of the bounds of the space, because we know that it's not going to be anywhere else on the snake because it's the head is the one that is always moving first. So to do that, if we envision that this is our window here, this top element is going to be 0, 0, and the bottom element over here is going to be 800, 600. So anything that would be a negative X or Y coordinate would be invalid, and anything that would be greater than 800 or 600 for the X or Y coordinate respectively would be invalid. Let's go ahead and write that code. All right, so we're checking for invalid width or invalid height. If either of those things happen, then we remove first, otherwise we remove last. Now we need some way to indicate that the game is over. Game over equals true. So now we have to define a game over field. Game over will start out as false. Now how else do we want to use game over? We still want to print out the snake even if the game is over. Move we're not going to want to do if the game is over, and we don't need to do any collision checking if the game is over. So if game started and not game over, we're going to move. Let's go ahead and try it out. Hey, there we go. Our snake stopped. So now we're in the game over state. So now let's go ahead and implement controls for being able to move our snake around with the arrow keys. We already have a listener that picks up when the spacebar gets hit. Let's go ahead and update that listener to also check for when the arrow keys are hit, and then we can have our snake move depending on the arrow key. All right, so the implementation of our overridden key pressed method within the anonymous inner class here is going to get more complicated. So I'm going to have the IDE extract this method, refactor extract method into snake game. And then I want the name of this extracted method to be handle key event. And now I'm going to add some code that basically is going to say if the game has not started, we're going to listen for spacebar. If the game has started, but we're not in a game over, then we're going to listen to the arrow keys. All right, so now if the game is not yet started within our handle key event method, if the user presses a space, we're going to start the game. And then on the next frame, as long as the game isn't over, if the user enters in up, down, right, or left, then the direction is going to shift in that direction. And also, I did create a direction enum here, up, down, right, left. And basically what we do is at the end of every frame in the move method, we update the direction to what the direction was that we just set up here. I'll get into why here in just a second. But basically, if we were to run the code as is, the problem is even though we default the starting direction to direction.right, within our move method, we're still assuming that the snake moves to the right every single time. And the code that needs to change is right here. So what I'm going to do now is I'm going to refactor this to change the direction of the snake's movement depending on what the current direction is. All right, so now we have a switch expression here, which takes the direction that we're currently in, and then it maps the new value of where the head of the snake should be in the current frame. And then after that, we're going to repaint it. Let's go ahead and run the code and try it out. All right. And there you have it. We can now control our snake. Let's go ahead and have it run into the corner right here. Not quite the corner, but sweet. So now we can move our snake around and we can see when it collides with a wall, the game stops. And I'm hitting more arrow keys. I'm hitting the space bar. Game's over. I should probably print some sort of message indicating that, but I'll get to that here in a little bit. So one thing that, at least in my opinion, is wrong with this implementation is a snake should not be able to do a 180-degree turn like this. It should have to do 90-degree turns. It should have to behave like this, not this. So let's go ahead and update our code to make sure that if we are attempting 180-degree change, that we prevent that. All right, so basically what we do is when we are accepting keystrokes, we want to make sure that the direction is not the opposite direction here. And that's also why we have this new direction variable, because within a single frame, you could change the direction multiple times. So if, let's say, we overwrote the direction value directly here, what would happen is if you had two different keystrokes, let's say you were going up and then you wanted to go down, if you entered left then down 10 milliseconds apart each, then you would effectively be doing the same thing where you're doing 180-degree turn within a frame, and we shouldn't be able to do that. So that's why we have the new direction variable, and that's why we add these extra protections here. Let's go ahead and make sure that that works as intended. All right. No matter what I do spamming this, I can't seem to get it to do 180-degree turns. Excellent. Now, another thing you might be thinking about when you see me doing this is I'm thrashing the directions, and I've got another method that gets called every frame that interprets the direction. Do I need to have any sort of concurrency protection here? The answer is surprisingly no, and that's because in Swing, a lot of the event handling is done in a single event thread. And because of that, we don't have to worry about concurrency issues. All you have to worry about is lag in the application if you're taking too long to execute event handling code. So in our case, don't need to worry about concurrency, you just need to worry about too much lag. So I think our snake is getting hungry. Let's go ahead and generate some food for our snake, and then let's see if we can make our snake grow when it touches the food. All right, so this is our method for generating food, which may not be super intuitive initially, but basically what's happening is we have this food field, and as long as our snake is not currently sitting on the food, meaning contains, contains means that it iterates over the array list, and if there are no elements in the array list that equal the current one, then you're okay. And the reason that we know that equals is good is because we made a record for our game point, which means that we are comparing equality of each of the fields and we're not using the object.equals implementation or anything like that. So this contains check should do what we want it to do. So basically we're going to generate a random place on the board where food is going to go as long as the snake is not currently on it. And that's where this random comes in. And what we're doing right here is we're making sure that the random spot corresponds with the particular area within our grid where our cells line up for where the snake could be. It wouldn't make a lot of sense if our food square was slightly offset from the snake square, so we're making them so that they're all within the same overall grid. So now let's actually draw the food. I'm gonna do set color, let's do cyan. Make it pop relative to green, but also the black background. And then what we'll do here is similar to last time. We'll do fill rectangle, except we'll do food.x, food.y, and then the cell sizes. Let's go ahead and run it and see what it looks like now. All right, and there's our food. But you'll notice, if I can actually touch the food here, I'm going right through it. I'm not eating it. So I need some way to indicate when I've eaten the food that the snake needs to grow and the food needs to respawn. So let's go ahead and do that next. To do that, we'll go into the move method, and now we've added the new head of the snake. If this happens to be where the food is, we're actually going to leave everything as is. So we're adding the new head position to the snake here. And if we happen to be doing this right where the food is, then we're not going to change much of anything. So if new head dot equals food, and now what we want to do is we want to generate food again. And then this can be an else if, and we know that we're not going to have a collision on a frame that we're eating food because the food is restricted by the width and the height of the window. So with that small code change, let's go ahead and run it again and see what it's doing. All right. Aha. We have a snake game. And we are eating the food and we are growing longer. And now I lost. Okay. All right, so now we've got the basic outlines of the game, but there's still some things I want to change. The first one is the appearance of the snake, I think, could change depending on how long it is. I kind of like the idea of the end of the snake being a little darker. That keeps it a little more interesting, if you ask me. The other thing is I want an indication when the game is over, and I want some way to restart it again. Because it's kind of annoying if I have to rerun the program each time that I die, because sometimes it takes me 10 seconds to die and other times it takes me a minute or two. And then the last thing is I want to know what my score is. So usually I think of the score as it starts out at 1 because the snake head is one element, and then the length of the snake is the rest of the score. And while I'm at it, let's say that I'm competing with my friends. I want to see who can get the highest score. So let's see if we can make a few more changes to the code to add in some of those extra features. So first, let's go ahead and spice up the look of the snake slightly. The idea is that whenever we're going to repaint our snake, so up here, instead of it always being green, we're going to modify the color depending on where on the snake we are. All right, so basically what we're doing here is we set the initial color to green. I need a semicolon right there. And then for each element in the snake, we are basically taking 95% of the green hue and we are applying that going forward. So as the snake gets longer, the tail is going to get darker. This 95% here is just kind of my general idea of how quickly the darkness should happen. If you want it to taper off faster or slower, you could tweak that number and see what you think. So as we are building up the snake here, we can see that the color does change slightly. I know this is going to be a hard one. Aha. All right, I'm getting into this too much at this point. I think you guys get the idea. We can see that the snake color does change. And I like that better. I think it makes the snake a little more interesting. Maybe 95% is a little too slow on the tapering and it should taper faster. Maybe 90% is better. But point being, I think that adds an extra little bit of color, no pun intended, to the game. So next, let's go ahead and add in a message here, which indicates the score that the user received at the end when they had the game over. We wouldn't want this as another if else if, because if we were to add an else if here, then we wouldn't be drawing the snake anymore. And personally, I like seeing the snake for a while, even after the game over. So let's go ahead and add it here at the end. If game over. All right, so we refactored a little bit here to have a print message method, which does some of the logic we had for the start screen because it's going to be the same for the game over screen. Let's go ahead and run it and see what it looks like. All right, so I got a score of 9. Sweet. But this does remind me, there is another thing we need to think about, and that is when you're playing Snake, if the snake hits itself because you're so good at the game that you can get a really, really long snake, that is also a game over. So we need to cover another case for when there's a collision, and that is when the snake hits itself. Let's go ahead and do that next. All right, so refactoring the isCollision method just a little bit here. We find that there's actually a pretty easy way to check this, and that is if you're familiar with the difference between a list and a set verifies you don't have any duplicate elements based off of what the key criteria is. And in this case, with hash sets, we're comparing hash entries, and we know that the equals and hash code methods of records are highly reproducible based off of the actual values of the record. Therefore, if you have a collision, meaning that the snake is wrapping on itself, then you're going to have the snake's head touching another element on the snake. Therefore, two elements in the snake are going to be equal, and the hash set is going to have a smaller size than the snake size. So actually, the collision case means that these are not equal. So when that happens, we know that the snake size is, let's say, 9, but the hash set size is only 8, meaning that we have a collision between the head and the body of the snake. I'll try this out and make a big snake to see if we can cause the issue to show up. All right, so here's a great example. The head of our snake is right here, and it collided with the body, so that's considered a collision even though it didn't hit any of the walls. So it seems like that code is working as intended. So next, let's update the code so that we don't have to restart the game every time, and the user can just hit the space bar again to reset everything. And I'm going to do that within the handle key event method here. If game's not started, so we're not entering this if statement. If we're not game over, we are now game over. So now in here, we can add an else if key code equals key event.vk space. Then game started equals false, and we can say game over equals false, and we're going to reset our game data. And now that we have that support, we should indicate on the screen how you do that. All right, looks good. Let's go ahead and try it. So we're playing the game, and whoops, game over. Can I press spacebar? Yes, I can. And now the game is reset. And now this is probably a little petty, but I like some way to track the current high score. So what I'll do is I'll maintain a high score variable, and we'll carry that along for the duration of the application. All right, now we've got a high score variable, and then we're going to compare it to the current score. Let's see how this looks. Okay, so that time I only got 4, so the current high score is 4. If I play again, I only got 2 that time, and the high score is still 4. Let's see if I can beat my high score. All right, and that time I hit 22. And that was today's snake game. I had a lot of fun both writing that code as well as playing the game to see what high scores I could get. I'm by no means an intense gamer. I casually do it periodically, and my reflexes aren't what they used to be. So my high score currently is 42. If anyone scores any higher than that, or if you want to share your score, please feel free to do so in the comments below. I'll be kind of curious to see what kind of scores you guys get. If you enjoyed this video and like this kind of content, please do smash that like button. I'd really appreciate it. Thank you for watching. I hope you have a good rest of your day, and I hope to see you next time. Take care.